Hello. Today we're going to talk about the second day of Chapter 4, and we're going to be on page 4 of our Chapter 4 notes. I'm hoping yours are in color. I think this might be pink on your colored copy. But we're going to talk about functions more because they're so important in what we do this year and what you're going to do in other math classes beyond Algebra 2. There's a special kind of function that's called a one-to-one function. And we'll talk about that a little bit more on the next video, but I'm just going to introduce you to the concept of how you can tell a function is one-to-one or not. We can easily tell if a function that has a graph is one-to-one by performing the horizontal line test. And I call the horizontal line test the HLT for horizontal line test, so I don't have to write it out all the time. It's pretty long to write. And if you can remember from the last video, or maybe from your Algebra 1 class, you can do a vertical line test. I call that a VLT, and that will just determine if a relation is a function or not. But then you can do a second test, and the second test is a horizontal line test, and if it passes both the vertical and the horizontal line test, then this function is a special one. It's called one-to-one. So, like I said, in order for a function to be one-to-one, it must also pass the horizontal line test. So sometimes that's a little bit tricky to keep track which is which. Vertical line test is for a function. Horizontal line test is for one-to-one functions. So this question says, which is a one-to-one function? Well, here's a curvy function. If you perform a vertical line test on it, you can see that a vertical line would only pass through this graph once. So this is a function, yes, because it passes the VLT. But when we do a horizontal line test, when we draw a horizontal line through this, look how many times it passes through the graph. 1, 2, 3, 4, 5 times. So we say it fails the horizontal line test. And so that means this function is no, not one-to-one. And I abbreviate one-to-one with the 1-1. So this is not a one-to-one function, this curvy one, even though it is a function. It is a function because it passes the vertical line test, not one-to-one because it fails the horizontal line test. Well, here's an exponential function. It's called. We'll learn about those more later this year. But if you do a vertical line test, it will pass. It only passes through. It only touches the graph once. And if you do a horizontal line test, it will also only hit the graph one time. So this passes both the VLT and the HLT. So it is one-to-one, yes. And here's another, just a straight line linear graph. It passes the vertical line test. It passes the horizontal line test. So this passes both the VLT and the HLT. Maybe I'll go have myself a BLT later. It makes me hungry. Anyways, so this means it is one-to-one. Yes. So this is just something to do on your own. It's just asking, and if you can remember from the previous video, those rules, if you have an equation, here's an equation, 2x squared equals y plus 5. Is this a function, yes or no? And so you can look at your rules on the previous pages to tell whether or not this is a function, and you would answer it over there. We can go over these in class. And how about this one? X squared plus y squared equals 16. Is that a function? Well, you can kind of think about this graphically. What would this look like on a graph? What would this look like if it was graphed? And if you can imagine those two graphs, then you can kind of perform a one-to-one, or you can perform a vertical line test also on it to see if it's a function. I'm not asking if it's one-to-one, I'm just asking if it's just a function. Is every line a function? I wonder. Here's a line. That's a function. That'll pass. What about a horizontal line? How about a vertical line? Every line is not a function. The answer is no. And that is because vertical lines fail the VLT. And the reason it fails a VLT, if you can imagine, let's draw a vertical line right here. If you draw a vertical line and then you try to perform a vertical line test on it, let's see how many times, if I draw this vertical line, how many times it would pass through this line. Gosh, it hits at every single point, every single point. So a vertical line touches that, a vertical line test will touch this original vertical line in an infinite number of places. So, no, because vertical lines fail the vertical line test. What about this one? Is this a function, yes or no? I'm hoping that this is an easy question for you. And is this a function, yes or no? This is a parabola. This will have arrows on both ends, and so will this have an arrow. That won't make a difference on whether it's a function or not, though. So is it a function, and is it one-to-one? We can talk about that in class tomorrow. Let's move on to page 5. On page 5, we're going to get into function notation. This is how you would write a function using a shortcut or an abbreviated way. This notation, f of x, that's just another name for a function, but it's another name for y. This f, this is the name of the function. It doesn't have to be an f. It could be other letters, but let's just say the name of the function is f. And a lot of times we use f because f is the first letter of the word function. So this is the name of the function. And this in parentheses, this x, this is a variable. Usually you'll use x, but you don't have to use x. Sometimes you'll use a letter t for a t variable, or an a, maybe sometimes your variable is a. But most commonly we'll see f of x, and that's how you say it, f of x. F of x is how you say this. And so, like I said, the name of the function is f. The variable that we're going to be plugging into this function is the x. So this variable is x. And f of x is just another name for y. So whenever you see f of x, you can always replace it with a y. And down here I say, although f is the most frequently used letter for function notation, like I said, because function begins with a letter f, a lot of times you'll see g and h as names of the function. So if you see a g as a name of a function, you might see g of x. Or if you see h as the name of a function, you can usually see it as h of x. And there are other letters that are used too. It doesn't have to be f, g, and h. It really could be anything. And it doesn't have to be lowercase. Sometimes they're uppercase. So now if we have an equation that says y equals 3x squared minus 5, if we want to figure out what that value is, when y is equal to, what is y when x is equal to -2? What we can do is we can take this y out of here, and y is just another name for f of x. So we're going to replace this y with f of x. And we can say f of x, because it's the same, really the same thing as y, f of x is equal to 3x squared minus 5. So that's our definition of this function. It's a function definition. I'll put DEF for the definition of that function. And now if we want to figure out what y is when x is equal to -2, we're going to replace the x with a -2. That's a substitution. So substitute x with -2 in this. So what this becomes is, instead of f of x, we're going to take that x out of there and put a -2 in its place. So f of -2 is equal to 3, and now we're going to replace that x. Any x we see, we're replacing it with a -2. 3 times -2 squared minus 5. And if we want to know what that value is when x equals -2, you can just do the multiplication and subtraction. So -2 squared is 4. 3 times 4 is 12, and 12 minus 5 is equal to 7. So f of negative 2 is equal to 7. That is the summary of that. F of negative 2 equals 7. We can evaluate this at any number we want. We can plug in a negative 1. We can plug in a 0. F of 0 is equal to 3 times 0 minus 5, which is just negative 5. So anything that we want to replace x with, we can, and it actually doesn't even have to be a number. We can put a letter in there, like we can do f of a if we want. F of a is 3 times a squared minus 5, for example. So let's find let's evaluate some functions. So this section right here, this is called evaluating functions. So we're going to find f of 3. So anytime we have an x, we're going to replace x with the number 3. That's what this means. Replace x with a 3 every time we see it. Let me zoom in a little bit here. So this becomes f of 3 is equal to negative 2 times 3 plus 4. Negative 2 times 3 is negative 6 plus 4. That's equal to negative 2. So our answer in the answer line would just be negative 2. The next one, f of negative 1. Well, what is f of negative 1? Anytime we see an x, we replace it with negative 1. But be careful. Make sure when you're squaring a negative number, it goes in parentheses, because negative 1 squared is a positive 1. So then we have minus 3 times negative 1 plus 4. So what that is equal to, negative 1 squared is positive 1. Negative 3 times negative 1 is a positive 3 plus 4. So 1 plus 3 is 4, and 4 is 8. So we would put an 8 on the line. And the last one, f of 10. Replace the x's with 10s. Well, there's only one x. So 4 times 10 minus 15. 4 times 10 is 40, and 40 minus 15, well, 40 minus 10 is 30, minus another 5 is 25. So we've got 25 here. So that's how you evaluate functions. It's just a substitution, or you replace the x with whatever is in parentheses. So here's a couple on your own that I would like you to do. See what you get, and we can go over those in class tomorrow. Make sure you get those okay. So you can shut off the video for a minute if you want to, because the last part of this page is really important. This last page, I have a graph of a function. Here's the graph of the function. Well, I'm asking, is this a function? Yes, it is a function, because it passes the VLT. If you draw a vertical line, it'll only touch it once. Is this a one-to-one function? No, it's not one-to-one, because if you draw a horizontal line, it passes through twice, at least, or maybe even an infinite number of points down here. So those are just basic questions about this graph. But up here we have a function that's defined with an equation. Down here we have a function that we have graphed. Do you see this little f of x here? This little f of x says this is the graph of a function. So if we want to do f of 3, everything in these parentheses, if you remember, x is in the parentheses, so all these values in here, this is really important. So I'm hoping that everybody's paying attention right here. These numbers are x values. So what we're going to do is when x equals negative 3, we want to know what y is. That's what this number is going to be. When x equals negative 3, what does y equal on this graph? So we're going to go over to this graph. We're going to go back to x equals negative 1, negative 2, negative 3. And then we're going to go up to this point right here. Zoom in a little bit further even. All right, so what's going on here? What is that point? That point here is negative 3, positive 3. So what I'm saying is when x equals negative 3, we're going to pick off this point right here. This point is negative 3, comma 3. And so when x equals negative 3, y equals 3. So f of negative 3 from the graph is 3. Over here it says when x equals negative 4, because that's what's in parentheses. When x equals negative 4, what is y? So we're going to go over here to negative 4. We're going to go up to this point. This point right here is negative 4, comma 4. So when x is negative 4, what is y? Y is 4. So these values right here that we're listing here, these are y values. So let's put an equal sign. F of negative 4 equals 4. What is f of 0? So what I'm saying is when x equals 0, what is y? Well, let's go over to the graph. When x equals 0, here's the point right here. This point is 0, comma 2. So when x equals 0, what does y equal? Y equals 2. And I'm going to go a little bit quicker now. When x equals 1, go over to x equals 1. Here's the point right here. This point on the graph is 1, comma 2. So when x equals 1, y equals 2. And then f of 5, when x equals 5. What does y equal? Well, let's go over to this graph right here. Oh, when x equals 5, look at, there's no point. There's no point on this graph, so when x equals 5, this function is undefined. That means there's no point. So we'll just write undefined, because there is no such y value when x equals 5. So that's a little bit tricky. So hopefully that's a good explanation. Anytime you see a graph, when you're asked to evaluate f of a particular value, these are going to be the x values. You just go over to the graph and find that x value, and you figure out what y is for that particular point, and that's how you define it. And that's the end today.